Chapter 8, Section 5, Systems of Linear Equations and Linear Regression. Do you want to know how a few numbers can predict the future? Let's solve it together. Have you ever wondered how computers figure out the best way to predict prices, customer behavior, or even tomorrow's weather? Behind many of these predictions is a simple but powerful idea: solving a system of linear equations. In this section, we will uncover how linear algebra is the foundation of linear regression, one of the most important tools in data science and machine learning. And don't worry, we will walk through a concrete example step by step using real numbers to make everything crystal clear. Let's take this simple dataset as an example. It contains two independent variables, x1 and x2, one dependent variable, y, and three data points. If we develop a linear regression model to approximate the relationship between the independent variables and dependent variable, the regression model can be expressed by this equation. This equation consists of these vectors. And we can simply express this equation in this way. Let's swap the left and the right sides. Let's find the optimal parameter values of this linear regression model by using LU decomposition. For clarity, let's rename the matrix and to align with the notation used in the previous explanation of LU decomposition. So, these are the matrix A, vector x, and vector b. By doing so, we can express the linear regression model as AX equals B. The first step is LU decomposition of matrix A. We have already known each element of the matrix A. In general forms, the matrix L and U can be expressed in this way. To solve for L and U, we will directly compute the elements by multiplying the matrices L and U and matching them to matrix A. Let's start with this equation. By multiplying the two matrices L and U, we can obtain this matrix. Since this matrix equals the matrix A, we can obtain the values of the first row. So, we can obtain the values of the elements in the first row. Let's substitute these values. Repeat this process, we can find the values of all elements in the matrix L and U. Now, we have obtained the values of all elements in the matrix L and matrix U. We already have the matrix L and vector B with concrete values of all elements. So, using them, let's set up the system. Next, let's solve for each variable step by step. First, solve for y1. y1 equals 8. Next, substitute y1 equals 8 into the second equation to solve for y2. We can find that y2 equals 2 and y3 equals 1. So, the solution for y is this vector. Now, let's apply backward substitution to solve ux equals y. Let's set up the system of equations. Let's start with the third equation, as it only involves x3. We can find that x3 equals 1. We can substitute this value into the second equation to solve for x2. So, we can find that x2 equals 2. Finally, we substitute x2 equals 2 and x3 equals 1 into the first equation to solve for x. We can find x1 equals 1. So, we have solved for x, and the solution to the system of equations is expressed by this vector x. To summarize, using LU decomposition, we first decompose the matrix A into L and U, then solve the equation Ly equals B using forward substitution, followed by solving Ux equals Y using back substitution. This gave us the final solution for x1, x2, x3. The vector x represents the optimal values of coefficients of the linear regression model. So now we have the linear regression equation. Solving for coefficients in linear models is a fundamental task in data science and machine learning. By representing models as systems of linear equations and using techniques such as normal equation, we can determine the best fitting coefficients that capture the relationship between features and target variables. Understanding how to solve for coefficients is essential for building accurate predictive models, optimizing performance, and making data-driven decisions. Thank you for watching. Please thumbs up and subscribe to my channel.